This video is going to introduce you to pyramids. We're going to talk about what a pyramid is, the different parts of a pyramid, how to find the surface area, and how to find the volume of a pyramid. If you want to read through the description of the different parts of a pyramid, just go ahead and pause the video and you can read through that and start the video once you're done. But basically what it does, it talks about the two main parts of a pyramid. The first part being the base. The base of the pyramid is just going to be like the polygon that makes up the bottom. It can be any type of polygon that we want. It could be a triangle, it could be a trapezoid, it could be a hexagon, it could be a pentagon. As long as it is a polygon, it can make up the base. So this is the base down here of my pyramid. The other part that makes up a pyramid are called the lateral faces. The lateral faces are just going to be everything that makes up the pyramid that's not the base. In a pyramid, the lateral faces are always going to be triangles, and they always meet at a one point, and that one point is called the apex. If you haven't already done so, go ahead and open up the assignment in Canvas that is 11.1.2-3, Volume and Surface Area of Pyramid. The very first question is asking you to identify these parts in your assignment: the slant height, which is the distance from the center of any of the lateral faces or the triangles to the apex, and it is perpendicular to the base of that triangle. The lateral edge is just one of the edges of the lateral faces, and then the height goes from the apex and straight down to the base and is perpendicular to the base. For question number 2, we're going to look at the Trans-American building in San Francisco. It is built of concrete and shaped like a square base pyramid. The building is periodically power washed using 1 gallon of cleaning solution for every 200 meters of surface. As the new building manager, you need to order the cleaning supplies for this large task. The problem is that you do not know the height of each of the triangular faces of the building. You only know the vertical height of the building from the base to the top. What we want to do now is determine the amount of cleaning solution needed to wash the Transamerica building if an edge of the square base is 96 meters and the height of the building is 220 meters. Drawing a sketch might be helpful. So what I've done here is I've drawn a sketch of the Transamerica building. It says that the edge of the square base is equal to 96. So that means that this is 96 down here. And it says the height, so from the center to the apex, is going to be 220. In order to find the area of the lateral faces, which are triangles, I need to find the slant height, which is this dotted line right here, that will give me the height of that triangle. To do that, I'm going to use the Pythagorean theorem. Since it's a square base, I know if I take the length of the side and divide it in half, that will be right in the center where the line comes down from the apex. So if I take 96 and divide it by 2, that's going to give me 48. So now all we have to do is use the Pythagorean theorem. So I'm going to do 220 squared plus 48 squared is equal to my slant height squared. And when we use slant height, we use the lowercase l, and it's usually italicized when we do that. So now we're going to use the Pythagorean theorem. When you put that in your calculator and do the square root, you're going to end up with 225.1755. Now, in the instructions, it asks you to round this to 4 decimal places. So be sure to round it to 4 decimal places when you enter the answer for the slant height. Otherwise, in a later part of the problem, you probably will not get it right. So here's another view of the pyramid. If we were to cut it along the lateral edges and then we were to lay it out flat, it would look something like this. So you have the 4 sides that are all triangles and you have the base that's in the middle. From the previous problem, we said that we had the slant height was equal to 225.175. So I'm just going to write that number over here, 225.1755. And since it's a square base, I know that's 96. So we've already answered the question for the slant height. Now let's answer the question for the area of the base. Since the base is the square, all we're going to do is do 96 squared, or 96 times 96, and that will give me the area of the base is equal to 9,216. The lateral surface area is just going to be the area of all of the triangles that make up the pyramid. Since we have it laid out over here, I'm just going to do the math over here. The area of a triangle is equal to base times height divided by 2. So the area is going to equal the base, which is 96, times the height, 225.1755, divided by 2. That will give me the area of just one of those triangles. If I want to now find the area of all 4 of the triangles, I need to multiply this entire answer by 4, and that will give me the lateral surface area. And when I plug all that in my calculator, we end up with 43,233.7. Then to find the total surface area, I just need to add the area of the base plus the lateral surface area. And when I add those two together, it gives me the total surface area, which is 52,449.7. The last thing we're going to do is now answer the question that we were asked in the beginning. How many gallons of solution will we need to wash the building? We have to be a little bit careful here, because when I'm washing the building, I don't need to wash the base. I only need to wash the sides. So I need to take the lateral surface area, which is 43,233.7, divide that by how many gallons you can wash, or how many square feet you can wash with each gallon. So you can wash 200 square feet with each gallon. And when you do that division, you'll end up with 216.17. And that's how many gallons you'll need to wash that area. This slide goes along with number 3 in your assignment. It is the volume of a pyramid. When we're talking about the volume of a pyramid, or the volume of anything, it's the amount of space that it takes up. If you look at the diagram that we have here, I want you to notice that both the base of my pyramid and the base of this rectangular prism are the same size. Also notice that the height of my pyramid and the height of my prism are the same. Now, it's easy to see by looking that the volume of the pyramid is smaller than the volume of the prism, because there's all that empty space in there. And as it turns out, it's true that it is exactly 1/3 the volume of the prism. Now, there's a video at the bottom of this question where it says question help, and that video will show you a demonstration showing that the volume of a pyramid is 1/3 the volume of that prism. So if you want to pause this video and watch that one, it's a pretty quick video, only about a minute long. So now let's just put in a couple of labels and see what we come up here. It says the height of the pyramid. Well, the height of the pyramid is given to us. The height of the pyramid is just 20. It's the same as the height of the prism. What is the area of the base of the pyramid? Well, the area of the base, since it's a square, will just be 10 squared, or 100. So now the volume. I can use either one of my volume formulas. I usually like to do base times height divided by 3. So that would be my base, which is 100. And actually, I should back up just a second here. The capital B in my formula stands for the area of the base. Just like when we were doing the volume of a prism, where the capital B stands for the area of the base. So for my pyramid, the area of the base is 100 times the height, which is 20, and I divide that by 3. And when I put that in my calculator, I end up with 666.67. This goes along with question number 4. I'm not going to walk through this one. I wanted to include it in the video just so you can kind of take a look at it and so you know where you're at in the video. But why don't you try this one on your own? So here we're going to take a look at number 5. In number 5, we have a square-based pyramid where we're given the slant height of the pyramid, and we need to find the volume and surface area. To start off, the first thing I want to do is I want to find the height of the pyramid. So the height of the pyramid is this distance right here. In order to do that, I'm going to have to use the Pythagorean theorem because I have a right triangle. Now, in order to find the height, I need to find the length of the bottom first. Since it's halfway between the two sides, it's going to be 10, which is half of the length of this side of the pyramid. So to set up the formula, we're going to have something like 10 squared plus h squared is equal to 34 squared. So if I solve for h, I'm going to subtract 10 squared from both sides. So I have h squared is equal to 34 squared minus 10 squared. Then we have to do the square root of that in order to find h. When you do that, you end up with 32.4962. So the height of the pyramid is 32.4962. Be sure to round to 4 decimal places here, or later on you might run into some rounding errors. The next thing I want to do is find the area of the base. The base is just going to be the bottom in this case, so that's going to be this part right here. Since that's a square base pyramid, all I need to do is say that the area is equal to base times height. Since they're both the same this time, it'll be 20 times 20, or just 20 squared, which is 400. To find the lateral surface area, what I need to do is find the area of all of the triangles that make up the pyramid. Well, we know the slant height, which is the height of the pyramid, and we know the length of the base, which is the base of the triangle. So we have the height of the triangle and the base of the triangle. So the area of a triangle is base times height divided by 2. So the base of my triangle is 20, the height of my triangle is 34 divided by 2, and that will give me 340. Since there are 4 sides, that means we need to take 340 times 4, which will give me 1360. Now, to find the total surface area, I just need to take and add the base area plus the lateral surface area. Well, my base area is 400, and I just noticed over here that I wrote down 4,000 instead of 400. That should just be 400. Plus the lateral surface area, which is 1360, which will give me 1760 for the total surface area. Now, to find the volume of the pyramid, volume is going to be 1/3 the area of the base times the height. So that'll be 1/3 times 400 times the height, which we found earlier is 32.4962. When you multiply all that together, you get 4,332.83. And this is our last question on the assignment, and it is number 6. And it just talks about a different type of pyramid called an oblique pyramid. In a right pyramid, I want you to notice that the height drawn, in other words, from the apex to the base and perpendicular to the base, is just right in the center of the base. That's called a right pyramid. An oblique pyramid is when the apex is not above the center of the base. In this case, it's off to the side over here. But regardless of whether it's an oblique pyramid or a right pyramid, the volume formula is the same. Now, the surface area formula will be different, and we won't be dealing with that in this course, but the volume formula will be the same. So let's go ahead and solve this. First thing we do is we have the height of the pyramid. Well, the height of the pyramid is given to us in both these cases. It's just 12. The area of the base. Since the base is the square, we're just going to do 10 squared, which is 100. And then to find the volume, we do the area of the base times the height divided by 3. The area of the base is 100 times the height, which is 12, divided by 3. And when you put that in your calculator, you should end up with 400.